All right, just a word of warning. The series that you see in example 4, they are not going to be as straightforward as the series we encountered in example 3. All right, let's take a look. Example 4, write the terms for each series and if possible, evaluate each sum. The series in part A is given by this expression. You've got your sigma notation. The lower limit of summation is 2. The upper limit of summation is 5. You've got an index indicated by I, and the terms of each sequence is given by this expression where you have B and the subscript on B is I. Okay, so the way we do this, we know we need to add up the terms between I equals 2 and I equals 5. So let's go ahead and write down I equals 2. We need to write down the corresponding term of the sequence. We get that by going to our expression here in blue and plugging in 2 for I. But look where the I is. I is the subscript. So if I is 2, the term of the sequence is going to be B2. That's all you can do. We don't know what B2 is. Perhaps what this is, you have some sequence given by B, like the terms of the sequence are B1, B2, B3, B4, B5, B6, B7, B8, and so on. We don't know what they are, okay? So this is as far as you can go as far as coming up with the terms of the sequence, okay? So we're done with I equals 2. So now we've got to bump it up to I equals 3, okay? Again, all you can do is go to your blue expression and plug in 3 for I. So if I is 3, the corresponding term of the sequence is going to be B3, okay? B3 probably equals some number, we're just not privy to it, okay? Keep going. Now we're going to go up to I equals 4, okay? All we can do is plug in I equals 4 into the blue expression to come up with the term B4, okay? Lastly, we're going to stop at I equals 5 because that's the upper limit of summation. Again, all we can do is replace I with 5. So the term corresponding to I equals 5 is going to be B5. Okay, so what's the answer here? Well, we have to add up the terms of the sequence. Okay, so this is going to be B2 plus B3 plus B4 plus B5. And because we don't know what the values of these things are, this is as far as we can go. This is the answer, okay? We're not going to get a specific number here because we do not know the values of B2, B3, B4, B5. If we had them, we would plug them in to get an answer, okay? So this is as far as you can go. Something I do want to mention here, this series does indeed converge. We don't know the number though, okay? This is not a situation where you have a series diverging. This is a finite sequence at the end of the day. You're only adding 4 terms. We just don't know the values of those 4 terms. But because this is a finite sequence or finite series, it will converge. Okay? Moving on to part B. Brand new series. Okay? This time the index of summation is given by J. The lower limit of summation is 1 and the upper limit is 4. And we're going to be plugging into this expression. This blue expression tells us how to come up with the terms of the sequence. Okay? So, again, this is different from what we've seen before. Okay? We have this extra information. Okay? So let's get started and just see what happens, okay? We are going to start with J equals 1, okay? So what we're going to do is go to our blue expression here. Everywhere you see a J, replace it with 1. So we're going to get 2 times xj. J is the subscript on the x. So we're going to replace j with 1. So that means that we have 2 times x1 because j is the subscript on x. Okay? Then we have to continue. We have to write minus 5. Okay? Now, what we can do here, we are told what x1 is. x1 is 3. So we can go a step further. This is going to be 2 times 3 minus 5, which is 6 minus 5, which is 1. So what happens here is that the first term in the sequence here is going to be 1. Okay, so it took a couple of steps to get the first term. Okay, now we're done with the first term. We're going to bump up our counter j by 1. So we're going to look at what happens when j is 2. All right, go to your blue expression, pop in a j value of 2. This is going to be 2 times x. The subscript on x is going to be the j value, which is 2 here. So it's going to be 2 times x2 minus 5. Okay, so this is going to be 2 times, we are given the value of x2. x2 is 5. Okay, so this is going to be 2 times 5 minus 5. This is going to be 10 minus 5, which is 5. So the second term in the sequence is going to be 5. Okay? All right. We're done with the second term. We need to bump up j again to be 3. Okay? Plug in j equals 3 to our blue expression. We're going to get 2 times x3 because j is the counter on the x. It's the subscript. Minus 5. Okay, when we look at this, x3 is the same thing as 7. Okay, so pop that value in. This is going to be 2 times 7 minus 5, which is 14 minus 5, which is 9. So the third term is going to be 9. Okay, we've got to go one more time because we stop when j equals 4. Okay, so we're going to have j equals 4. Pop it in. Okay, go to your blue expression. Replace j with 4. So we're going to get 2 times x4. 4 is the subscript here. Minus 5. This is going to be 2 times x4. Okay, let me use a different color that I haven't used yet. Let me see. I'll pick orange. Okay, so we are told that, let me see, I need a highlighter here. Hang on. All right. We are told that x4 is the same thing as 9. Okay, so now we can make that replacement. Okay, so this is going to be 2 times x4 is 9 minus 5. This is going to be 18 minus 5, which is 13. So the fourth and final term that we need is 13. Okay, we're not done. All we did was generate the 4 terms that we needed. To compute the value of the series, we have to add up these 4 numbers. Okay, so the answer is going to be 1 plus 5 plus 9 plus 13. We're adding A1 plus A2 plus A3 plus A4. Okay, and then that will be the final answer. Okay, so I'm going to go to the calculator. I'm going to do 1 plus 5 plus 9 plus 13. So the series converges to 28. Okay, that's the answer. Okay, this series converges to 28. I can add it up to a specific number. Okay, all right, let's look at the series in part C. Again, it looks pretty complicated. Okay, all right, this time we've got our sigma notation. We've got to add up. The lower limit of summation is 1. The upper limit is 3. The index of summation is given by k. And then here is the expression that defines the terms of the sequence. Okay, it's even stranger than part B. Okay, it's f of xk times delta x. Okay, again, you've got this information out to the side that you're going to have to use. Okay, if you notice, we've got a function involved this time. Okay, f of x is equal to 1 over x. Then we're told the value of x1, the value of x2, the value of x3, and the value of delta x. This specific notation that you're seeing in part C here, this is something like you're going to see at the end of Calculus 1, okay, where you start first working with sequences in series, okay? So again, you've got a function that you're dealing with, 1 over x. You've got specific values for x1, x2, and x3. Then you've got this quantity delta x, and what this represents, it's a small distance along the x-axis. Okay, so here delta x is like an increment of 4 units along the x-axis. Okay, that's not important here for computing the series. Okay, I'm just trying to explain what you're seeing. Okay, let's go ahead and figure it out. This is going to be a finite sequence. We're only adding up the first term, the second term, and the third term. So it's going to converge to some number. Okay, again, it's key that you be able to read the notation here to put this together. Okay, we're going to start with k equals 1. Go to the blue expression. Everywhere you see a k, pop in a 1. This is going to be f of x1 because the k is the subscript on the x. Nowhere else do you see a k. You have to multiply by delta x. Okay, I need to get a number out of this. I have all the information that I need. Okay, so f of x1, that means go to the function and plug in an input of x1. So go to your function. Everywhere you see an x, replace it with the input x1. So this is going to be 1 over x1. Okay, that's f of x1 times delta x. Okay, keep going. 1 over x1. What is x1? Well, x1 is 1. Okay, so it's going to be 1 over 1 times delta x, and we know delta x is 4. Okay, so we have to multiply the 1 by 4. So the first term here is going to be 4. Okay, you had to be able to read the notation to go from, the one piece of the puzzle to the next, okay, to put this together. Okay, that's the first term. Now I'm going to bump it up to k equals 2. Go back to the blue expression. Everywhere you see a k, replace it with 2. So the term in the sequence is going to be f of x2, okay, times delta x. Okay, now when you look at f of x2, that means you're going to the function in green here, f of x. You're plugging in x2 for x. So everywhere you see x, replace it with x2. So you're going to get 1 over x2. That has to be multiplied by delta x. Okay, so we're going to get 1 over, in the denominator has to be x2. x2 is 3. So this is going to be 1/3 times, again, delta x is 4. Delta x is constant. It does not change. Okay, so this is going to be times 4. So the answer here is 4/3. That's the second term in the sequence. Okay, We have to go one more time until we achieve the upper limit for k. So now we're going to pop in k equals 3. Okay, go to the blue expression. Everywhere you see k, replace it with 3. We're going to get f of x3 because k is the subscript on x. We're multiplying by delta x. Okay, f of x3 means plug x3 in for x into the function f. So everywhere you see x in the green function, replace it with x3. So we're going to get 1 over x3 times delta x. Okay, so now we just plug in the information. Okay, I missed some highlighting here, so let me fix that. All right, so we're going to have 1 over x3. What is x3? I'm running out of colors here, so I'll pick pink. Okay, so x3 is, oops, that's too close to what I had. Let's see here. Let's use, I guess, a light blue. All right, we are told that x3 is 5. So I'm going to pop that in. So I'm going to get, this is going to be 1 over 5 times delta x. Again, delta x is always going to be 4. That does not change. So I'm going to put 1/5 times 4. So this is going to be 4/5. Okay, we're done because 3 is the largest k value that we can go to according to the upper limit of summation. Okay, so to evaluate the series, we need to add up these 3 terms. Okay, so we need to take the 4 and add 4/3 and add the 4/5. Okay, add these 3 terms up. Okay, so let's go to the calculator. We're going to have 4 plus 4/3 plus 4/5. Okay, and we get a nasty decimal, so let's go ahead and hit math, option 1 to convert it to a fraction. So this series converges to 92 over 15. Okay, that's the answer here. Okay, and I will write at the bottom here, this series converges, because it's finite, to the number 92 over 15. Okay, from this example, all 3 series that you looked at, you can see how important it is to be able to read the notation involved with series.